Good morning, students. In the previous class, we have seen the basics of trigonometry. Yeah, we have seen the basic 6 ratios. Do you remember the 6 ratios? From sin theta, cos theta, cosecant theta, secant theta, cot theta, and tan theta. Okay, we have solved a sum about that. Okay, in the next topic, now we are going to see about trigonometric ratios of some special angles. Okay, what are the special angles? They are 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. Okay, first now we are going to see about 45 degree. Yeah, let us take 45 degree and derive the values for this 45 degree with six ratios. Okay, let us start. First we now draw a diagram. Okay, let this be a square and this is its diagonal. Okay, let us now mark the diagonal. Okay, let us take the side of the square be a. Okay, then this side also be a. Okay, with the help of Pythagoras theorem, we can now find the diagonal of the square. Yeah, we know that each angles inside a square is 90 degree. With this we can now find the diagonal of this square. Okay, then let me ask a, b, c and d. Okay, by Pythagoras theorem, AC square, that is take the triangle ABC. In triangle ABC, AC square equal to AB square plus BC square. Okay, then AC square equal to both AB and BC are same as they are the sides of the square. A square plus A square equal to 2A square. Now take square root on both sides. Then AC equal to root 2 of A. We have found that the diagonal of the square. Okay, now the diagonal bisects either angle, you know that. Then this angle be 45 degree and this angle also 45 degree. Yeah, then take this triangle. In the triangle ABC, yeah, angle CAB is 45 degree, right? This angle CAB equal to 45 degree. Okay, then keep this angle, now this angle be the 45 degree. Then take the sine of this angle, sine 45 degree. We know the formula sine theta equal to opposite side by hypotenuse. Here the opposite side is BC, BC by hypotenuse AC. What is the value of BC? We have taken as A by the hypotenuse. We found that root 2A. Now just a minute, is root 2A. Now we can cancel the A, the remaining it will be get 1 by root 2. Then we got the formula as sin 45 equal to 1 by root 2. We have derived the formula for sin 45 degree. Okay, similarly we can now prove that we can now found the formula for cos 45 degree. Cos 45 degree, what's the cos formula? Cos theta is adjacent side by hypotenuse. Adjacent side here is AB by AC, with is nothing but A by what? Root 2A, that is hypotenuse. AA got cancelled. The answer is same answer. We got that sin 45 degree and cos 45 degree as 1 by root. Okay, now we will find the tan 45 degree. Okay, tan 45 degree, what's the formula of tan? It's opposite side by adjacent side, that is BC by AB. Opposite side by adjacent side. What is BC here? A. Then adjacent side AB is also A. Then we got cancelled. Then we have found that tan 45 degree equal to 1. Yeah, now we know from this 3, yeah, what is sin 45 degree, cos 45 degree and tan 45 degree, we can find the remaining ratios. Yeah, cosecant 45 degree, it is nothing but the inverse of sin 45, that is reciprocal. What is sin 45 degree? 1 by root 2. If the denominator goes to the numerator, it will reciprocate, then we will get only root 2. Likewise, from cos 45 degree we can find secant 45 degree. Yeah, secant 45 degree is the inverse of, that is a reciprocal of cos 45 degree, it is nothing but 1 by root 2. It's the same as root 2. Then cot 45 degree is the inverse of tan 45 degree. Tan 45 degree value is 1. Now we have found the 6 trigonometric ratios for the angle 45 degree. Okay. Now we will find the 6 trigonometric ratio for 30 degree and 60 degree. Okay. Let us take an equilateral triangle. Okay. Mark the side sets A, B. Oh, you will take another. Okay. We will take another markings. Right. P, Q, R and M. Okay. We have said that this is an equilateral triangle. Mark each side as 2. Then whole side will be 2. Now let PM be the angle bisector. Angle bisector means what? This PM bisects the angle P into 2 equal parts. Okay, these 2 angles be equal. If the angle bisector meets the opposite side, it divides the opposite side into 2 equal parts. That means QM is equal to MR. We already know that the length of QR is nothing but 2. Then if the angle bisector divides the 2 into 2 equal parts, then the QM equal to MR. That is, here it takes value 1, here it takes value 1. In the equilateral triangle, we know that each angle is 60 degree. Yeah, we have studied in the previous class. Then this is 60 degree. Then this is 60 degree. Okay, we know that the angle bisector in a right angle triangle is 90 degree. That is perpendicular to the base. Yeah. Okay. We can see that in this triangle one angle is 60 degree, another angle is 90 degree. Then this angle what will it be? It will be 30 degree. Why? We have already said that sum of the interior angles in a triangle is 180 degree. Yeah. We already know that we have already 60 degree plus 90 degree. We need to buy the remaining angle that will be take as x degree equal to 180 degree. Then add to this, it will get what? 150 degree plus 60 degree equal to 180. Take the 150 in the right hand side. 180 degree minus 150 degree. Okay, then x value will be 30 degree. That's what we got here as 30 degree. Okay. Likewise, in this triangle also, this angle will be as 30 degree. Okay. With this diagram, we will find the ratios, 6 trigonometric ratios for 30 degree and 60 degree. Okay. First, in the triangle PQM, take the triangle PQM. In the triangle, sine of 60 degree. This angle, sine of 60 degree. Okay. Sine of what will be? Opposite side PM by hypotenuse. This is also a right angle triangle. This, okay, mark this 90 degree. What will hypotenuse? PQ. Okay. First we need to find the value of PM, right? Then only we can substitute. Using the Pythagoras theorem in any 2 triangles. These 2 triangles are similar. Okay, we can find in any one triangle. Let's take the same triangle PQM, this first triangle. Okay, we need to calculate in the same way as we calculated in the previous square sum. Okay, that is the sum of the other 2 sides except hypotenuse. So the square will be equal to the sum of the square will be equal to the square of the hypotenuse. That is PQ square is equal to QM square plus PM square. Okay, what is the PQ? Is 2 square. QM, it's 1 square. PM we need to find out. Okay, 2 square is 4, 1 square is 1 plus PM square. Take this one in the left hand side. 4 minus 1 equal to PM square. Then 3 equal to PM square. From this we can take square root on both sides. Then PM equal to root 3. We find the remaining value. Okay, PM. Mark here. This is root 3. Okay, come here to the previous step, sine 60 degree. Now we have found the PM value is root 3 and PQ value what is 2. Then sine 60 degree equal to root 3 by 2. Yeah, we have found the sine 60 degree value. Similarly, next we can find cos 60 degree. This is the adjacent side. QM by PQ. QM value is 1, PQ value is 2. Then cos 60 degree equal to 1 by 2. Now we can find tan 60 degree. Tan 60 degree equal to, what is here, the 60 degree opposite side by adjacent side, that is PM by QM. PM value is root 3, QM value is 1. Yeah, right. Then tan 60 degree equal to, what is the answer? Root 3. Yeah, right. Okay, let me write in the combine. That is sine 60 degree equal to root 3 by 2. Cos 60 degree is equal to 1 by 2. Then tan 60 degree is equal to root 3. From this we can find the remaining ratios, right? Cosecant 60 degree. Yeah, cosecant 60 degree. This is inverse reciprocal of sine 60 degree. 1 by 60 degree. Yeah, this way 1 by root 3 by 2. If we get inverse, it will be what? 2 by root 3. Okay, from cos 60 degree you can find secant 60 degree. This is nothing but 1 by cos 60 degree. 1 by 1 by 2. If it get in the numerator, it will be 2. Then cos 60 degree. Yeah, that's nothing but 1 by 60 degree, tan 60 degree. Tan 60 degree value is root 3. Nothing but 1 by root 3. Yeah, we have found the 6 trigonometric ratios for the angle 60 degree. Okay, with that same, with that same triangle, we will now find that the 6 ratios for 30 degree. Let me mark the same value here. Yeah, P, Q, R, M. We already found that values, right? What are the values here? 2, 2. Here root 3. This is 30 degree. This is 60 degree. This is 90 degree. Okay. Okay. Now we found that. Now we will find the 30 degree ratios. Take this angle in triangle. Same PQM. Right. Sine 60 degree. Sine 30 degree. Yeah. Now we find 30 degree. Sine 30 degree equal to what is for this 30 degree? Opposite side is QM. Hypotenuse is what? PQ. QM is nothing but 1. PQ is 2. Sine 30 degree is 1 by 2. Then cos 30 degree. Cos 30 degree is what? Adjacent side here. The adjacent side for 30 degree is PM. PM by PQ. Right? Hypotenuse. What's the value of PM? Root 3. PQ is 2. Next, tan 30 degree. Tan 30 degree is nothing but opposite side by adjacent side. For 30 degree, opposite side is QM. Adjacent side is PM. The value of QM is 1. Value of PM is root 3. Tan 30 degree equal to 1 by root 3. Okay, from these ratios, now we can find the remaining values, right? Cosecant 30 degree is nothing but 1 by sine 30 degree. Yeah, sine 30 degree value is 1 by 2. If it gets a numerator, is 2. Okay, then it is secant 30 degree. There is nothing but 1 by cos 30 degree. Right? What's the value of 1 by cos 30 degrees? Root 3 by 2. If it gets in the numerator, it will be root 3 by 2. Then remaining is cot 30 degree. It's nothing but 1 by tan 30 degree. Tan 30 degree value is 1 by root 3. You need to get numerator root 3. Now we have found the 6 trigonometric ratios for 30 degree also. Yeah, this is full of 30 degree. Okay, for 30 degree we have found here. For 60 degree we have found here. Right, this is full for 60 degree. Okay, then what are the remaining angles? Okay, the remaining angles are 0 degree and 90 degree. Right. Okay, for these two angles we directly go to the formula. Just remember the value for sine 0 degree is 0 and for cos 0 degree it will be 1. From these two values we will find the remaining values. You already know that tan 0 degree. It is nothing but sin 0 degree by cos 0 degree. Yeah, then 0 by 1, it will be 0. Okay, next cot 0 degree is nothing but the inverse of tan 1 by 0. When we get a new value as 0 in the numerator, in the denominator, it is written as not defined. Not defined, because it will take infinity number of values. In the mathematical term, we will generally define it as not defined. Generally write it as non defined. Then leave it. Then secant theta. Secant 0 degree, nothing but the inverse of cos 0 degree. What we have find? We know the cos 0 degree 1. 1 by 1 is nothing but 1. Then remaining value is cosecant 0 degree, nothing but 1 by sin 0 degree. Sin 0 degree value is 0. Yeah. Similarly, this cosecant 0 degree is also at not defined, because it tends to infinity value. Okay. Now we have found every value for 0 degree. Now we come to 90 degree. Just remember the same as two formulas, that is sin 90 degree is equal to 1 and cos 90 degree is 0. From these two values we will find the remaining values. Okay, tan 90 degree is nothing but sin by cos, that is sin 90 degree by cos 90 degree. What is sin value of sin 90 degree? 1. Cos 90 degree 0. If we get the 0 in the new denominator, it will be not defined. The value we get not defined. Then cosecant 90 degree, this is nothing but 1 by sin 90 degree. Sin 90 degree value is 1. 1 by 1 is 1. Then secant 90 degree. What is the value of secant 90 degree? 1 by cos 90 degree. Yeah, cos 90 degree is 0. Anything by 0 is not defined. Okay, then cot 90 degree. Just cot 90 degree equal to 1 by tan 90 degree. Tan 90 degree is not defined, but we have got the value previously as 1 by 0. When we get it goes to numerator, it will be 0. Yeah. Now we have find the 6 trigonometric ratios for every angles. Okay, let us make the table. Okay, trigonometric table for every angles. Okay, just a minute. Yeah, let me draw a table. Just a minute. Okay, let me write here angles here: 0 degree, 30 degree, right, 30 degree, 45 degree, 60 degree, 90 degree. Let me write trigonometric ratios here: sin theta, cos theta, tan theta, cosecant theta, secant theta, last is cot theta, right? Okay, now let me write the each values here. Okay, we found the sin theta is what? 0. Sin 30 degree 1 by root 2. Sin 30 degree is 1 by 2. Sin 45 degree 1 by root 2. This is root 3 by 2. This is 1. For cos theta, just write the sign values for every in reverse order. 1, root 3 by 2, 1 by root 2, 1 by 2, 0. Now it's get easier to remember. Then tan theta, we know that sin by cos, we already found the value, just we will write the values. Tan theta equal 0 equal to 1 by root 3, 1 root 3 not defined. Okay, next cosecant. Cosecant is the inverse of sine. Okay, this is not defined. 2 root 2 2 by root 3. Next 1. Second is inverse of cos, which is 1 2 by root 3, right, root 2 2, then not defined. Next cot is inverse of tan. This is not defined. Root 3 1 1 by root 3 0. Okay, yeah, we have completed the table. Just you can see that sine values get reversed in cos values, then tan value gets reversed in cot values, then cosecant values get reversed in secant values, right? You can easily remember, but you need to get every values remembered in every time. This will be used in the coming form exercises. Okay, yeah, next we are going to see the trigonometric ratios for complementary angles. What is the complementary angle? Yeah, when we add two angles, let's say A and B, if we get the sum of their sum, there's 90 degree. That is, when we add two angles and when we get, and the answer is get 90 degree, then these two angles are said to be complementary. Okay, then what is meant by supplementary? When we add two angles, if we get the result as 180 degree, this is called as supplementary. Remember, this will be gets applied in coming chapters. This is complementary. Yeah, in the previous classes we have learned about acute angles and obtuse angles, right? When the angle is greater than 0 degree and less than 90 degree, it will be called this as acute angle, right? Okay, in this right angle triangle, this, if we mark this angle as theta, then definitely the remaining angle will be 90 degree minus theta. How will we get that? Means sum of angles in a triangle is 180 degree. Okay, then this value will be 90 degree minus theta. These two angles will be theta and 90 degree minus theta will be exactly, that is, it will be always acute angle triangles, that is less than 90 degree. Yeah, in a right angle triangle only one angle will be 90 degree, the remaining two angles will be always acute angle, right? Okay, now we will be find the ratio, six ratios for this theta and 90 degree minus theta. Then we will relate that to separate ratios and we will derive some formulas. Okay, first we will find for theta. What is sin theta? Will be AB by AC, right? Sin theta is opposite by AB, then hypotenuse AC. Then cos theta will be BC by AB, then tan theta will be AB by BC, right? Next we can find that cosecant theta nearby. I will write here nearby. Cosecant theta will be the inverse of sin theta, right? Then secant theta will be inverse of cos theta, AC by BC. Then cot theta will be the inverse of tan theta, BC by AB. Okay, so similarly this we have found this all values for theta. Now we can find all values for 90 degree minus theta, right? Now we can find. Okay, yeah, sin 90 degree minus theta for this value, right? Sin degree minus, the opposite side will be BC and the hypotenuse same as AC. Okay, the value is BC by AC. Then cos 90 degree minus theta will be AB. For cos 90 degree minus theta, AB is adjacent side, AB by AC. Then tan 90 degree minus theta will be BC by AB, right? Then similarly we can find cosecant 90 degree minus theta, which is the inverse of sin theta, will be AC by BC, right? Then secant 90 degree minus theta will be inverse of cos theta, that is AC by AB. Similarly cot 90 degree minus theta, inverse of tan theta, nothing but AB by BC. Okay, now compare these two sets of theta, assume we has just generally as theta and 90 degree minus theta. By comparing, we can see that this sin theta is equal to cos 90 degree minus theta, right? Then you can see that this cos theta is equal to sin 90 degree minus theta. Yeah. Then this tan theta is equal to, here what? AB, where is the AB? Here tan theta equal to AB by BC. See, clearly you can see that the tan theta is cot 90 degree minus theta, right? From this we can derive that, see here sin theta is equal to cos 90 degree minus theta, that is sin theta is equal to cos 90 degree minus theta. Then cos theta is equal to sin 90 degree minus theta. Then tan theta is equal to cot 90 degree minus theta. Okay, in the same way we can say that just a minute. Yeah, from the by comparing these two, we can say that cosecant theta is equal to secant 90 degree minus theta. Compare here, cosecant theta is here, AC by AB is, see here, this is also AC by AB, that is secant 90 degree minus theta, right? Then secant theta is equal to cosecant 90 degree minus theta. See here, secant theta is AC by BC, cosecant 90 degree minus is also AC by BC. Yeah, by comparing we can derive this formula. Then cot theta is equal to tan of 90 degree minus theta, that is tan 90 degree minus theta. See here, cot theta is BC by AB, tan 90 degree minus theta also is equal to BC by AB. Yeah, from this we have derived 6 formulas, that is sin theta is equal to cos 90 degree minus theta, then cos theta equal to sin 90 degree minus theta, the reverse, and tan theta equal to cos 90 degree minus theta, and cot theta equal to tan 90 degree minus theta. Yeah, see here, cosecant and secant is in a relation, and secant and cosecant is in a relation. Yeah, we have now found some 6 formulas. Okay, we have done, we have, okay, keep remember this every formulas we have taught today, and you should remember in every time. Okay, okay, the next chapter, the next class we can see the trigonometric identities and how we use this trigonometric ratio in the real life, and how we will measure some distance objects such as a tree or a building. We can even measure the distance of galaxies and stars with these trigonometric formulas. Okay, these are the application oriented concept in the trigonometry. Okay, okay, hope you are good. We can see in the next class.